Hey guys, Mr. Barnes here again, bringing you another trig derivative video. And this one is an example where you have to use the quotient rule, You have to use the quotient rule. So those of you who don't remember, I have the quotient rule written out here to your right. And this is something that you are expected to know. And you know, the reason we know we have to use quotient rule here is because we have two functions that are being divided. So cos x divided by x squared. So, you know, a pretty typical example. So my g is x squared, so y prime is equal to x squared times the derivative of f. Well, the derivative of cos is negative sine of x minus, and then we have, I'm just going to erase a little bit of this guy so I don't get in the way. Derivative, so we have f, well f is cos x, so cos x, times the derivative of g, well g is x squared, so the derivative of x squared is 2x using the power rule. And then that's all divided by g squared, so g is x squared, so x squared all to the 2, so that's going to be x to the 4. So I end up with, I'll just rearrange it a little bit, x squared times sine of x minus cos x. Actually, I'll put the 2x first, just to make it look a bit nicer. 2x cos x, all divided by x to the 4. And then, you know, what's common here is there's an x in both, so I can reduce that down a little bit just by reducing the denominator to x to the 3 and then eliminating x in both of these top terms in the numerator. So I end up with x sine x minus 2 cos x all divided by x to the 3. And that looks pretty good. So there's our final answer. So again, guys, the important thing to remember about trig derivatives, no different than the other derivatives that we did, is that you need to remember your rules, product rules, chain rule, quotient rule, things like that. All the rules that we learned before all apply to all the same things with trig. So hopefully this example helps, and I'll see you guys in class.